Hello, everybody. We're going to continue with learning about how to compute probabilities for normal distribution using Excel. Now, we're moving to the fourth example where we're looking at standard normal probabilities. And this section, we'll end up using some of these tools quite often when we do confidence intervals estimation and hypothesis testing. So please pay attention. So for the first question, for the remaining 6 questions here, we're going to deal with a standard normal distribution, which is generally denoted using the letter Z or Z, and it has a mean of 0 and standard deviation of 1. Now we want to find the probability of the standard normal distribution from lying between the areas 0 and 2.25. So let me very quickly show you how we could think of visualizing this. So if I draw a bell curve like this, okay, then a standard normal bell curve is one whose center is at 0, the mean being 0, okay? And the particular question asks us to find the area between 0 and, so 1 is here, this would be, we're looking at 2.25, okay? So we want to find the area. So probability of 0 less than Z less than 2.25 is given by this particular shaded region, okay? And why I am shading this will become apparent once we move to the second part of the question. But now let me go back to my Excel sheet. So we want to find the area between 0 and 2.25, and we'll do that by using our cumulative functions this way. Okay, lesser than or equal to 0. And I'm just following the same principles that we used in the previous video. So this will be norm.dist 2.25 0 1 true, norm.dist 0 0 1 true. And turns out about 48% of the area is between 0 and 2.25. And from the graph, we can see why and how that is the case. As always, check with the applet if your answers are correct. Now, the second question looks very similar to the first one, but the signs are a little flipped. We want to find the area or the probability of Z taking on values between minus 2.25 and 0. Now, I'm going to tell you that the answer to this question is going to be the same as the answer to part A. And that comes from the symmetric nature of the normal distribution or the bell curve. Now let me help you visualize why I say the answers have to be the same. So going back to our normal bell curve, if 2.25 here, so we're dealing with the Z distribution, standard normal. So we could think of 2.25 as being 2.25 standard deviations to the right of 0, because every Z score essentially measures the distance to the mean in units of standard deviation. So plus 2.25 will tell us that we are 2.25 standard deviations above the mean. And therefore, minus 2.25, which is here, should be equidistant from the mean, but on the other side. So we are 2.25 standard deviations below the mean. So if I want to find the area of minus 2.25 less than Z less than 0, I'm essentially talking about this particular zone. And I know that because of symmetric, these two have to be the same. The symmetric nature of the normal distribution because of symmetry. So the normal distribution, the two halves are symmetric, and therefore the area from minus 2.25 to 0 should be the same as the area from 0 to 2.25. Okay, and we'll use this point in a later problem as well. But now let's go back to our Excel sheet. And if we compute this as in the same way, norm.dist 0 0 1 true minus norm.dist minus 2.250, true, you'll get the same answer. And that's the beauty of the normal distribution being symmetric. And I'm going to leave the third question for you to solve. Okay. Now let's look at the fourth one. Or actually, let's do the fifth one and then come back to the fourth one. Now we have to do the reverse here. We're given the probability value and we have to find the specific point in the normal distribution. So we have to find Z1 such that the probability of Z being lesser than or equal to this point is equal to 0.6. Meaning we have to find the point Z1 such that the area to the left of that point is equal to 0.6. And we're going to use the norm.inv function to do this. So norm.inv, the first argument tells us area to the left of this point, which is 0.6. The mean of standard normal is 0, and standard deviation is 1. And you get the answer 0.25. So the way you'd want to visualize this is we go back to our worksheet. So you have to find Z1, okay, such that area to the left of that particular point is equal to 0.6. Now we know the area to the left of the mean is 0.5. So if we're looking at a point whose if the area to the left of that point is 0.6, then it has to be somewhere to the right of the mean. So it's perhaps somewhere over there. So this is Z1. And this entire area, we are told, is equal to 0.6. Okay. And when you use the norm.inv function, you specify the area to the left of that particular point, and then your standard normal parameters, and you'll get the answer. And this particular point Z1 is 0.2533. Okay. Now let's go back to our Excel sheet and solve the previous question. Now we want to find the probability, we want to find the value Z1 such that the area of the curve to the right of that point is 0.6. So how do we do this? So now let's try and visualize this. Now we're told that we have a bell curve. Okay. And we want to find Z1 such that area to the right of Z1 is equal to 0.6. Okay. So we have the mean here. Okay. And area to the right of a particular point has to be 0.6. So if area, so which means we essentially want to find a particular point Z1, which is maybe somewhere here, such that the area to its right is equal to 0.6. And why am I drawing Z1 to the left of 0? Because I know that area to the right of 0 has to be 0.5. So if I want to find a point whose the area such that the area to the right is 0.6, 0.6 is greater than 0.5, right? So which is why I take Z1 to be to the left of 0. Now I want to find this Z1. Now the trick to actually doing this in Excel is to remember that if this area is 0.6, this area is going to be 0.4. Therefore, I'll use the norm.in function in such a way that I'm just going to flip this way. Okay. And just by visualizing this, I'm able to write down the probability of the normal curve area to the left of Z1. And once I know this area, I can easily feed this into our Excel function and compute the answer. So this is actually P of Z. If Z1 is such that area to the right of Z is 0.6, then area to the left of Z1 is going to be 0.4. And here what I'll do is I'll do norm.inv 0.401. And you see how this value is minus 0.2533. And you see how this looks pretty similar to the previous answer. Now let's visualize that once more. So the answer here is that this Z1 is minus 0.2533. Now putting these two bell curves together, okay, so if I have 0 here, and I have minus 0.2533, and I have plus 0.2533, this area is 0.4, and this area to the right, oops, sorry, area to the right of this point will be 0.4. Now I'll let you spend some time with this chart and visualize and understand this symmetry even better. Now we'll solve the last one here. We want to find Z1 such that the probability from minus Z of the value Z lying between minus Z1 and plus Z1 is 0.9. Now, this may be a tad intimidating in the beginning, but let's use our handy visualization tool. So let me go back and draw my chart. So I have numbers going from, so I have a mean of 0. And I'm told that from minus Z1 to plus Z1, the area of the curve is 0.9. Okay. This entire area is 0.9, and we are asked to find the value Z1. Now, let's break it down. We know that the normal distribution is symmetric. Therefore, if this particular area encompasses 0.9 or 90% of the data, then half of it should be to the left of the mean and half of it should be to the right of the mean. That is, this area will be 0.45 and this area will be another 0.45. Okay. And when you add them, you will get 0.9. Now we know that area to the left of 0 has to be equal to 0.5. And if this chunk is taken up by 0.45, then area to the left of minus Z1 has to be 0.05. So now we know that probability of Z being lesser than or equal to minus Z1 is equal to 0.05. And once I visualize this, we can find minus Z1. And from there, we can find Z1. Now let's try that in our Excel sheet. So we want to find Z1 such that probability of Z being lesser than or equal to minus Z1 is equal to 0.05. Okay. This is norm.inv 0.0501. And what we actually have here is minus Z1, which is minus 1.644. And if we want to find plus Z1, all that we have to do is that multiply this by minus 1. And I can do that very easily in one line. Or what I'll do is I'll just put a minus sign in front of this and run the function. And that gives me the answer of 1.644. So when you go back to your chart, when you have data running from, let me use a different color. So this point is minus 1.644 and this point is plus 1.644. And that's your answer. And that's how you solve this problem. So always visualizing the normal distribution and understanding what the question wants you to find. Once you visualize it, it's much easier to answer these questions. So I have a couple more questions here, which I'll leave it as an exercise for you. So good luck.